So this is a part 3. Okay, let us find the value of a1, a2 and so on. a1 we've already got, that is a1 is equal to 0. Let us find now first a3, odd numbers. Okay, so when you put r is equal to 3 in this recurrence formula, k minus r is 3 plus 1, so this will be minus 2, and k minus 3 plus 2 is minus 1, and this will be 3 minus 2 is a1. Okay, similarly in the denominator. Okay, so a1 we already got, that is equal to 0. So let us substitute this value here. So it whole term becomes 0. It means a3 is equal to 0 because a1 is equal to 0. If a3 is 0, a5, a7, a9 we will be getting equal to 0. Okay, let us find now a2 values, a2, a4, a6, so on. Now let us use case 1 when k is equal to 1. Okay, we will change wherever n is there, that is equal to k. Sorry, where k is there, that is equal to n. Okay, now in this recurrence formula ar is equal to minus of, we will put now in place of k n minus r plus 1 c. Okay, again n minus r plus 2, and this is ar minus 2 as it is. Okay, so again n minus n plus r, so n get cancelled, only r remaining. N plus n, 2n, right, minus r plus 1. Okay, now in this we will put the value of r is equal to 2, 4, 6 and so on. Okay, now when r is equal to 2, a2 is equal to minus of n minus 2 plus 1 is n minus 1. N minus 2 plus 2 get cancelled, we will get n. Here 2n minus 2 plus 1 is 2n minus 1. So this is 2 minus 2 is a0. Now a0 value we will put here, that is this will rearrange now. N into n minus 1 we will write 2 into 2n minus 1 and a0. Okay, now okay, keep as it is this. Now let us put r value 4. Okay, here minus of n minus 4 plus 1 is n minus 3. N minus 4 plus 2 is n minus 2. This is 4. 2n minus 4 plus 1 is 2n minus 3, and this is 4 minus 2 is 2. So n into n minus 1. Now in place of a2 we have to substitute the a2 value. A2 value is what? Minus n minus 1. This minus and this minus get plus. So n into n minus 1 and this n minus 3 and so on, whole divided by, okay, 2 already there, this, and 2 into 2n minus 1 and this 4 into 2n minus 1. Okay, we are substituting a2 value, these two value in this a4 here. Okay, that is equal into a0. Here a0 is there. So all this value we have to put in the series solution, that is y is equal to summation from 0 to infinity ar x raised to k minus r. Okay, so let us put in this equation. See, this I have written the equation series, then ar x raised to, now let us change k value is what? n minus r. Okay, now what is the expandation form of this? I have already told in the starting only, a0 x raised to n. When you put r is equal to 0, x raised to n, and you put r is equal to 1, so it will be x raised to n minus 1. Okay, a2 x raised to n minus 2, a3 x raised to n minus 3 and so on. Okay, now let us put a0 x raised to n as it is. a0 is 0, a0. Okay, now this value a1 we got already 0, so no need to substitute. a2 value we have to substitute, minus of n into n minus 1 upon 2 into 2n minus 1 x raised to n minus 2 into a0 plus this 0. So a4 value will substitute n into n minus 1, n minus 2, n minus 3, so on. Okay, and this is a0 here, x raised to n minus 4, this as it is, upon this value. Now, okay, here from this all we can take a0 common. Remaining term let us write x raised to n, and okay, that is so on up to Put a0 is equal to, okay, let us assign value for this a0, 1 into 3 into 5 so on up to 2n minus 1 upon n. Then we have, okay, and this p y we have denoting for this legendary equation is pn of x, that is equal to y. Okay, so let us substitute a0, 1 into 3 into 5 to n minus 1 upon n. Okay, and this is x raised to n. This is as it is. Now this is called, function is called legendary polynomial or legendary function of degree n. Okay, now case 2, when k is equal to n, we solve the legendary function. Now k is equal to minus n plus 1. Okay, so we have to change k value as minus n plus 1 in that recurrence formula and find out the value all a2, a3 and a4 and substitute in this expandation form of the series solution, and we will get a different equation. Okay, that is left for you. You can try it.